Hello everyone. So it's day 23 and today I have 26th March the Hindu newspaper because on this day Indian Express has no issue because of the holiday due to the Holi. So there are a few important articles on the text and context page in the Hindu newspaper. So one is on campaigning in the name of religion. Campaigning in the name of religion. So what does Section 123 Clause 3 of the Representation of People Act 1951 stipulate? And what about the Model Code of Conduct laid down by the Election Commission of India? Have the courts ever convicted leaders for corrupt electoral practices? So we have to see these things in this article. So recently, Bharatiya Janata Party lodged a complaint with the Election Commission of India against Rahul Gandhi, hurting the sentiments of Hindus through his remark on Shakti. The DMK in turn filed a counter complaint against the Prime Minister for appealing to religious sentiments during his campaign on the same issue. So this is a thing which is going on. So what does the law say? Section 123, Clause 3 of the Representation of the People's Act 1951 provides that appeal by a candidate or any other person with the consent of a candidate to vote or refrain from voting on the grounds of his religion, race, caste, community, or language is a corrupt electoral practice. Section 123, Clause 3A denounces any attempt by a candidate to promote feelings of enmity or hatred among citizens on these grounds during elections. The RP Act further provides that anyone found guilty of corrupt electoral practice can be debarred from contesting elections for a maximum period of up to 6 years. So, what does the Model Code of Conduct provide? So, the MCC for the guidance of political parties and candidates is a set of norms which has evolved with the consensus of political parties. They have consented to abide by the principle embodied by in the said code. It binds them to respect and observe it in its letter and spirit. So this code, which began to be implemented strictly in the 1990s, provides that no party or candidate shall indulge in any activity which may aggravate existing differences or create mutual hatred or cause tension between different caste, religious, or linguistic communities. It also provides that there shall be no appeal to caste or communal feelings for securing votes. Mosque, church, temples, or other places of worship shall not be used as a forum for election propaganda. Though the MCC does not have any statutory backing, it has come to acquire strength in the past 3 decades because of its strict enforcement by the Election Commission of India. So, what has been the history? It is pertinent to note that before 1961, Section 123, Clause 3 of the RP Act provided that systematic appeal by a candidate on the grounds of religion, race, caste, or community will amount to a corrupt electoral practice. However, in order to curb communal, paras, and separatist tendencies, the word systematic was omitted through an amendment in the 1961. This meant that even a stray appeal for success in the election on the grounds of one's religion or narrow communal affiliation would be viewed with disfavor by the law. There have been innumerable instances in the past where various parties and its leaders have blatantly appealed for votes in the name of religion. So there are leaders across political parties against whom cases have been registered under the RP Act and the Indian Penal Code in this regard. However, the only notable leader who was convicted by the Supreme Court for this corrupt practice was electoral practice was Bal Thackeray of Shiv Sena in the year 1995. The ECI on such occasions at best bars leaders from campaigning for violation of the MCC for a short period of 2 to 3 days. So what does Supreme Court rule? So this is very important rule. Abhiram Singh case, Abhiram Singh versus CD, Commission 2017, a seven-judge bench by a majority of 4-3 held that candidate shall not appeal for votes on the basis of not just his or her religion but also that of the voters. The majority view provided a purposive interpretation to Section 123, Clause 3, rather than a just literal one, thereby rendering any appeal in the name of religion or even the voters as a corrupt electoral practice. The election to parliament or state legislatures are secular exercise. Constitutional ethos forbids the mixing of religious consideration with the secular function of the state. Religion should remain a matter of personal faith. So, what is needed? Political parties and candidates are likely to raise legitimate concerns of citizens faced by them on the basis of traits having origin in religion, caste, community, or language in a democratic election process. However, it should be to only address their grievances through appropriate policies without jeopardizing the secular fabric and fraternity of the country. Any appeal in the name of religion only results in the further polarization of our multi religious society. So, the place of worship have always been used overtly and covertly as a forum for canvas. Religious leaders have thrown their weight behind candidates of various parties. So these practices should ideally be avoided in order to ensure that politics and religion are not mixed up. However, the primary responsibility lies with the political parties, party leaders, and candidates. Their campaigns on the basis of religion not only disturbs the secular fabric of our polity but is also a clear violation of law. The ECI and courts should devise mechanism for swift action against those violating the law in this regard. So this is the article all about. There was one other important article regarding semiconductor, how they are made, used, and who manufactures them. So this is a very hot topic that is going on in news in recent time. So every country is trying to uh, build semiconductor on their own. India is trying its um most of the best efforts to make semiconductors in within the country. So let us see what this article is about to say. So semiconductor influence nearly every facet of our lives. Many of the solutions to the 21st century's most important crisis, including artificial intelligence, electric vehicles, space exploration, and environment monitoring, bank on a steady supply of the advanced semiconductor. So let us see what these are. While the physical realm of human activity contains an array of languages, the digital realm is founded on just one fundamental binary language, the ones and zeros, also called the bits of data. Computers represent these bits as electrical signals, and this forms the foundation of modern computing, communication, social media, robotics, constantly shape the way we interact with technology and with each other. And the beating heart of this binary revolution is the semiconductor device. So, what are the semiconductors? Semiconductors represent a distinct class of materials that possess some of the electrical properties of both conductors and insulators. Like a faucet, which can be used to control the flow of water, semiconductors can be used to control the flow of electric currents uh, and with exquisite precision. The most important type of a semiconductor is a transistor. At the dawn of the era of modern electronics, the first integrated circuits featured four transistors. Together, they controlled the flow of currents in such a way that the circuits could perform simple arithmetic operations. Today, we have single chips boasting billions of transistors. Fitting so many transistors on a teeny chip no bigger than a fingernail requires extreme precision and a microscopic eye for detail. For instance, the accuracy required is equivalent to dividing a strand of human hair into 1,000 segments, each of specific width, and further subdividing each segment into 100 parts. This is why fabricating semiconductors involve cutting edge technology and science. So, how are the semiconductors made? The process starts with an engineer carefully selecting a silicon wafer as the foundation on which the semiconductor will be built. A team puts silicon sourced from sand through a meticulous purification process to separate it from other substances until they have an ultra pure wafer with the impurity levels as low as few parts per billion. This percentage is comparable to an error of merely 1 centimeter while measuring the Earth's diameter. Okay, so next is the photolithography process, a crucial step that carves the circuit pattern on the wafer. The wafer is coated with a light sensitive material called a photoresist. Then a mask is held in front of the water and light is shined on it. The mask contains small gaps in the shape of the shape of the circuit pattern. The light passes through these gaps and erodes the underlying parts of the photoresist. As a result, the photoresist on the wafer acquires the pattern of the transistor circuits. Okay. So following photolithography, engineers use chemical and or physical techniques to remove the uncarved part of the photoresist, leaving behind the circuit's structure on the silicon substrate. Then they dope the semiconductor, that is, deliberately add impurities to a specific part of the semiconductor to alter its electrical properties and deposit thin layers of materials such as metals or insulators to the wafer's surface to form electrical connections or insulate components. Then the resulting product is packaged. Individual chips are separated, encapsulated, and tested to make sure they are functional and reliable and integrated into electronic devices. So, what does the fabrication landscape look like? So, each step in semiconductor fabrication demands ultra high precision and harnesses a blend of diverse scientific principles. For example, to make the most advanced transistors, the photolithography process requires a light source emitting electromagnetic radiation to a wavelength of 13.5 nanometer. To achieve this, the high NA-EUV machine made by the Dutch company ASML uses a cannon to shoot a 50 micrometer blob of liquid tin at 300 km per hour through a vacuum chamber, where laser beams blast it with enough energy to form a plasma that finally emits the requisite wavelength radiation. The semiconductor manufacturing process is characterized by a specialization leading to an oligopoly controlled by companies specializing in specific domains. So ASML, a spin-off of Philips, is in fact the sole provider of the photolithography machines for cutting-edge semiconductor technology worldwide. The American firms Synopsys and Cadence, Cadence dominate the software tools that engineers use to design circuits, while the silicon wafer sector is led by Japan's Shin Itsu. The market for the actual task of the fabrication is led by Taiwan's TSMC, with fabrication tools provided by Applied Materials and Lam Research, both headquartered in the US. The majority of intellectual property rights are held by British company ARM. So India boasts a leading role in chip design centered in Bengaluru. However, most of the intellectual property rights required to execute these designs are retained either by parent companies or by ARM, or relegating India to being a mere user of their products. This setup is akin to the McDonald's business model. While India may host numerous McDonald outlets, the recipe and supply chains are owned by parent company headquartered in a different country. Okay, so how do semiconductor benefits us? How do semiconductors benefit us? Smartphones and computers showcase the pinnacle of semiconductors technology, but semiconductors influence nearly every facet of our life. Semiconductors also power smart air conditioners' ability to regulate the temperature, as well as space telescope's ability to capture both inspiring and scientifically interesting images in the depth of the universe, and many other technologies in between. So many of the solutions to the 21st century's most important crisis, including artificial intelligence, vehicles, space exploration, robotics, personalized healthcare, and environmental monitoring, bank on a steady supply of advanced semiconductors, underscoring their importance for the survival of the human race and its aspirations of equitability, sustainability, and justice. Such semiconductor technology facilities foster innovation, create high-paying jobs, nurture the potential for deep tech startups, and both draw from and feed into advances in material science, computer engineering, big data, optics, chemical engineering, and chip design, to name a few. Owing to their role in sectors like defense and automotives, semiconductors have also emerged as a focal point of geopolitical interest, with the nations vying to establish semiconductor fabrication facilities within their borders and drawing industry leaders in with a plethora of incentives. The US also imposed sanctions on Chinese tech companies, including bans on the acquisition of cutting edge ASML equipment and high end design software for the same region. In response, China has intensified efforts to bolster its domestic semiconductor production capabilities to meet local demand. So, India, meanwhile, has been trying to use its expertise in design to establish semiconductor manufacturing plants. One hopes this strategic push plus the potential of our youth will translate to numerous opportunities for the country to seize the international semiconductor industry. So, this was about the semiconductors and why it is so important, and why countries are uh, focusing more on indigenization of the technology due to geostrategic advantages. So these are the few advantages of semiconductors. So for the next day newspaper, we'll meet next day.